So my name's Katy Hollbacher. I'm the founder and owner of Beyond Efficiency. We're a high-performance building consulting firm. I'm also on the board of directors of Energy Conservation Works. You're going to hear more about what that is when Jennings goes. And I also used to work with Max Moran. He's a board member at Lower Valley Energy. He'll introduce himself when he comes. But yeah, we're really excited to be here today. We're big believers that solar's great. A lot of these other technologies that do a better job creating energy in a more efficient way, but we really need to start with the source. Could you advance? Okay, that's all right. Okay, so I'm sure everyone's kind of... Oh, you brought the clicker up. Thank you. I'm not paying attention. And all right. Yeah. Well, that's okay. We'll just roll with it. So I'm sure you've all heard the question of, like, what's the cheapest kilowatt hour? Who wants to throw some ideas out? What's the cheapest one? The one you didn't need in the first place, because with better efficiency, we eliminated the need to even use that energy. So that is the cheapest kilowatt hour, the one we didn't even need to buy. So that is the first slide, but that's all right. Let's see if I can. Okay, there we go. Woo! And that's really the premise of what we're going to be talking about today, is to try to help everyone understand just how beneficial efficiency can be in these extremely cold climates. In Jackson, heating degree days is about 11,000. A lot of you probably have a sense of how extreme that is. We are one of the few zones, as well as some areas in Colorado that are climate zone 7, so very cold. So yeah, what we want to do is try to eliminate energy from needing to be used in the first place. So just a quick pop quiz. What percentage of energy would you guess the typical cold climate home, typical huge variation, but just, roll with me on this. Would you say that space heating and water heating contribute in, let's just say like a 2,000, 3,000 square foot cold climate home? Just throw some guesses out. 50 to 70%. All right. Yeah, you guys, you're the right crowd here. So, yeah, this, again, varies a lot. There's really no average, but in general, I think this is actually a pretty conservative estimate that we generally say at least half of annual energy use in a home here in Jackson is going to space heating, and a really large percentage is water heating, about 15%. Now, what do you think would happen in a bigger multi-family building with like maybe a higher occupant density, and it's kind of more efficient inherently because it's a bigger building with like a lower surface area to volume ratio? So what might change with this equation in like a big multi-family building? Any guesses? Yeah, that's a typical thing we see. Water heating starts to become a bigger and bigger deal, like in a bigger building, but that still has a high occupant density. And this is assuming code level building envelope and like a kind of standard heating. So something that meets code right now, which includes electric resistance, but also, the most efficient natural gas, propane boiler, furnace, whatever. This is typically about what we see. So, I think it's important to think about like what leads to needing a certain amount of heating, whether it's just sort of a chilly fall day or it's minus 20 on that coldest January morning at 7 a.m. So on one side we have heat losses, windows and walls, and air infiltration. Those are really what I call the big three in the typical residential scale home. Those contribute they really dominate the heating loads. And then we have ventilation, losses through roof and crawl space. And then on the flip side, though, if it's during the day, we're actually getting some beneficial heating that we want in the winter with solar gains, internal gains, cooking, lighting, whatever. And the difference between those, there are more losses than gains on a heating dominated day. So the result is the heating demand. So that is how many, BTUs an hour the natural gas furnace, the heat pump, the electric resistance cove heat, or whatever need to provide. So if, looking at this, what would be the places to start if we wanted to whittle down heating demand? That's what we're gonna get to. But the ideal premise is we want to, again, start minimizing heating demand by reducing losses. So architects building some really high-end custom homes hate to see this, but compact geometry is really, really impactful just simply reducing windows. Windows are the weak point in homes, especially if you have 50% of walls or 60%, which is often the case in some of the projects we consult on. That's just a lot of losses. So those are some things, and then once you hopefully have kind of optimized the design to start, then you get into highly insulated walls, envelope air tightness, triple pane windows. Those are the places to start to have the biggest impact. Then once you've again reduced a certain amount of heating from ever needing to be used in the lifetime of that building, you've got one time to get the envelope right. Maybe 30 years later there's some sort of retrofit, but definitely least expensive to do it from the outset. Then the question is, all right, so for the heating we do need, how can we optimize that? We're big fans of all electric, but that doesn't mean electric resistance. That means heat pumps. And yes, they work in cold climates. And then, things like tight ducts, make sure the heat is getting to where it's designed to go, thoughtful zoning, and obviously occupant education and habits are a huge thing, but we're not really focusing on that today. So, ugly slide, sorry about that, but the point here is if you were to take a efficiently designed box, just a rectangle, which I know is not the typical, but like a 2-story, 3,000 square foot home with kind of what for a lot of custom homes is a modest amount of glazing, 30% glazing, and you just apply all the base International Energy Conservation Code requirements to that we get a peak load of about 30,000 BTUs an hour, about 2.5 tons. Actually, that's really low in a really cold climate like Jackson. That is what the peak load would be. And this is how it breaks out. So again, you can see here, windows, walls, air infiltration, those are like the huge, the elephants in the room to deal with. So what if you wanted to reduce the load by half? That might kind of sound crazy. And you might think you've got to do like 3-foot thick walls and all other sorts of crazy things. But in fact, it's really not that big a deal, and we can get there pretty easily. So if we go to very high performance triple pane windows, U factor of 0.15, instead of 1 inch of outsulation, do 3 inches, R12, something like cork, EPS, polyiso, whole range of things. Roof. The roof was not a big contributor. We were already starting at R60, so you don't really get a lot of benefit from going to like an R100 roof. The only reason I even went to R68 here was because I was trying to show you how we can cut it in half. Otherwise, I'd planned to leave that R60 as is. Crawl space, don't even change the crawl space insulation, just R15 on the inside of the crawl space walls. And then, you get a huge benefit by really doubling down on airtight, on envelope air leakage. So this would be a passive house level of 0.6. Sounds scary to people that have never done it. In fact, if you just go into the design and construction of a home with intention and you just really have a continuous air barrier, it is not that hard to meet this. It really isn't. We've done it plenty of times. We've had buildings come in at 0.15 and 0.2 in that range. So this is like the best bang for the buck. And then do a little better in ventilation heat recovery. We've now cut our peak load in half. That means that the heating equipment only needs to put out, 16,000 BTUs an hour and not 31,000. It means that on those frigid days where maybe the grid goes down and the heating isn't working, rather than the home, tanking in temperature quickly over a matter of a few hours, it can ride those waves much better. And that's the notion of resiliency that is especially important when a utility wants to reduce its peak load. And Max is going to get into a lot more of that, being the LVE expert here, on how important peak load is, especially in a cold mountain town. So another kind of big graph here, but I think there's some misconception in our industry about the difference of like energy usage and demand and peak and what do all those mean. And this is just a graph I stole from Salem Electric. This is not what a typical energy usage curve would look like in Jackson in winter. We're going to actually see the peak when it's cold overnight, and then kind of go down during the day, and then probably peak again around 6 p.m. when everyone's home cooking and watching TV and stuff. But I think this is really important. So on the the left side we have power. What is the rate of energy usage? And then if you just multiply that by time, whether it's an hour, it's a day, it's a whole year, that's where you get the total energy consumed in a year. the difference between kilowatts and kilowatt hours. And what's really important here is that the peak, that's what directly contributes to your heating system size and how comfortable you are when it's, minus 20 out or not, or if you're not comfortable. So this is really important. And, if we kind of picture this graph showing peak in Lower Valley territory, which is what covers us here, being, that 7 a.m. January day when it's minus 20, if you think back to making all those envelope improvements, our peak, we've cut the peak in half. And that starts to have a big influence on how the utility, how much extra energy the utility needs to pay. And Max, again, is going to get into that more. So finally, again, the whole area under that is energy consumption. So that's what we think of if it's like, how much total energy is this home or multifamily building or office using in a year? That total or absolute quantity. Okay, so the typical Jackson home, and Max might have better stats on this, but the typical home in the town of Jackson, because we enjoy really cheap electricity, which we appreciate, especially when we're using inefficient electric resistance, so that we're not paying like $1,000 a month. But the typical Jackson home does have electric resistant space heating and water heating. And one reason, it's extremely inefficient, but again, energy is really cheap here. But we're getting to this point in Lower Valley where we're moving more and more out of kind of this core block of energy and have to pay for more expensive energy. So we need to really double down as a community to address the core demand for heating with better envelopes and also heat pumps. So that's the typical home. I think there's also a misconception about different types of electric resistance, like what's the most efficient? Oh, Cove Heat's great, it's really efficient. In reality, none of these are most efficient. They're all pathetic. One unit of energy in, you get 1 unit of heating energy out. We're just trying to force electrons a direction they don't want to go. That causes heat. 150-year-old technology. The concept of heat pumps, interestingly, has actually been around for like 170 years. And the first actual heat pump with refrigerant was built about 80 years ago. But fossil fuels have been, until recently, cheaper. And so it's just taken a long time to really get here, but we're now, thank goodness, in this time where people are recognizing the benefits and the efficiency of heat pumps. And obviously, technology has come a long way, too. So I'm not going to get into like how heat pumps work. We do want to try to leave some time for Q&A at the end. And by the way, if any questions do come up, definitely feel free to raise your hand. We'll answer things as they come up. But in essence, the idea of a heat pump is that it's capturing heat from the ambient air, until we're at like literally 0 Kelvin, which is what, minus 274 Fahrenheit or something like that. There's actually energy in the air. And down to about minus 13 or minus 15, technology works to still get useful heat out of the air. If you take air in a big space and you compress it, it will get hotter. That's just the kind of the core function. And then we use refrigerant to pump that heat to where we want it to go. So that is the core premise of a heat pump, and at least 2.5 times more efficient. 1 unit of energy in, 2.5 units out. And we're not talking 10% better, right? We're talking like 200% better, 300% better. So it's a really big deal. And Lower Valley, the numbers here are a little bit old, but they put some information on their website just to show the different costs to provide a certain amount of heating. And they were a little conservative, in my opinion, on what they assumed for like an air source electric heat pump. So I kind of crossed that off and made this more like a 2.5 COP instead of like a 2 COP, coefficient of performance or general, metric of efficiency. But you can see here, like, there's just no question. I think if everyone really saw this, people wouldn't be recommending electric resistance in a new home. So we've really got to get this education out there. Okay, so how this all kind of ties up, if we took just this notion of units of energy, just using 100 to make the math easy. And again, about 50 units of energy over a year will go to space heating, 15 to water heating, and then 35 to everything else. And by focusing on this optimized building envelope and ventilation, as well as heat pump, space, and water heating, you can drop the energy use in half. So what would happen if Lower Valley, as this utility, went all in partnership with the town of Jackson and Teton County to do these like volume portfolio level rehabs on homes? And we really got serious about aggressive energy codes. We don't have to assume an infinite increase in energy. We could really reverse this increase. And with that, I'm turning over to Max. So.
Thanks, Katy.
And maybe before you jump in, are there
Yeah.
any quick questions? And again, sorry to keep you waiting, but we'll try to not keep you too much longer.
Yeah, here, I'll hand this back to Katy.
Hi, Katie. In that last slide, you said that the potential for 50% reduction in energy usage, and with both of those attributes, one being envelope, one being heat pumps, what percentage of that 50% reduction is due to envelope versus the heat pumps?
The question was, if we went all in, looking at minimizing demand with better envelopes and then delivering the energy more efficiently with heat pumps, we can get to 50% reduction. Most of that is from heat pumps. The challenge with just heat pumps is we're still not, on those coldest days, if it's minus 20, and there is a not very well insulated home, it's like, maybe it's a condo in the village that was built in the 70s with like 2x4 walls. Even with heat pumps, those are going to be really efficient when they work, but if there is a day where it's minus 20, electric resistance needs to kick in, so we're not actually dropping the peak. So I'm a big believer that, it's both and. But in a lot of retrofit situations, it just makes sense. It's like, just put heat pumps in. Deep energy retrofit of like cloaking walls and insulation, putting in triple pane windows. It's like, it's really involved and expensive, and that's where like major funding is needed to make that happen. But yeah, there is a lot of benefit from just doing heat pumps. And I think we can still get to like a 40% reduction on the total, just doing heat pumps for space and water heating. Any other, yeah?
So with our cheap power, I've done the numbers for a heat pump for the model of our house, and it's not economic at all because the capital cost for retrofit with heat pump. And so where do we get stuck in that situation? Because the LVE incentives help some,
Yeah.
but still, we're getting return this.
Yeah, so the question is, like let's just say sort of an average home, we've got a lot of really huge homes with massive electricity bills, even though we pay 6 cents. But yeah, in a home where people aren't, paying that much, to be honest, yeah, the payback doesn't make sense for most people. And that's where I think we need to get smart at the regional level in tackling this problem on a portfolio basis and not just one by one. One-on-one. Now, Megan is going to go through a couple of case studies of rehabs which have taken advantage of the energy conservation works low interest loan paired with some Lower Valley rebates, and it really can help a lot. And then as soon as the IRA program gets going sometime next year, that's what I think really can make a big difference. But it's true. Like, it's one of those things. We all enjoy low energy usage, but then there's no incentive to save energy. There's little incentive. So but at the utility level there is, and that's what Max is going to get into now. So we will turn it over to Max. Oh, sorry, one more quick question. Yeah. Yeah, so the question is, when do heat pumps, kind of like stop working? Like, the typical cold climate equipment goes down to minus 13, minus 15. There is a GE product that says it can go to like a minus 30. We've never spec'd it, so I need to better understand that. Sorry. So yeah, that's the typical cutoff. But again, if you have a high performance home with triple pane windows, I would argue that we don't need to be designing to minus 30 in the town and county, which is currently the requirement. ASHRAE requirements are actually only about -15, but the county requires a much colder design temperature. But if if you have a high performance home that can ride through those, those cold spells, then it's okay if the heat pump, even if it does lock out, and you have maybe just a couple cove heat backup heaters. So that's something on our list maybe to lobby the county for. Okay, I'm going to turn it over to Max now.
Thanks, Katie. Hi, I'm Max. I'm a member of Lower Valley Energy and also board of director at District 6, which is serving the eastern half of Jackson here. So here we are. We are in Western Wyoming. We're a nonprofit cooperative. We serve about 21,000 members. Actually, it's a little higher than that. Those are some old numbers, but we have a really large service territory. We are all the way up in Yellowstone at the south entrance, and then all the way down to Afton and Alpine. We cover a portion of Idaho in Swan Valley, and then east of us in Bondurant. So that's the big question is, our power's so cheap, it's relatively clean. Is there a need to, have a high performance building? And so, the last 10 years, the last 20 years, probably not. There's no ROI, but I kind of want to just show what we're looking at in the next 5, 10 years and how, as a cooperative, we are, a collective entity, and we all kind of need to take ownership and like what's going to happen in the next 10, 20 years as far as rates. So yeah, a little bragging here, 5.5 cents a kilowatt hour. That's incredible. I mean, I'm sure there's some people here who are paying 15 cents a kilowatt hour, maybe even more. We might even have some California residents in here. Huh? Yeah. And what do you pay? Do you know what you pay per kilowatt hour?
Pretty close to that.
34 to 36.
Yeah. It's shocking, and it's certainly kind of made the argument for conservation kind of challenging. What was that?
That number I said is not the worst in California.
Sure. So I'll get into it briefly. Why is our power so cheap? So we are at the headwaters of the Columbia River. So we are entitled to power produced by the Columbia River system by BPA. So Bonneville Power Administration is a federally owned and operated entity, and we get to purchase power at cost. So there's no kickbacks on the generators. They're not making money. They're just selling it back to us at cost. And so for the longest time, this covered the vast majority of our load. Breaking it down, we're pretty heavy on the residential side, residential and then small commercial. So our shops and towns, our hotels covers 70% of our load. And then as Katy broke that down even further, the vast majority of that is going to heating. We're winter peaking, January, February, when the days are cold. We are, that's when we see our biggest demand. So here's, take some of these numbers with a grain of salt, and don't look at them too closely. But that bottom bracket there, that's our BPA power. And the y-axis there does not go to zero. So this is, we're still at 80, 90% BPA power. But we're experiencing load growth just like every other mountain town here. We're growing, and we're having to go out and purchase power just like everybody else. And it's 2, 3x what we're paying now. And that gap there in between where we're projected to be and what BPA covers is just getting bigger. And at the end of the day, we need to start seriously thinking about conservation because, the good times are kind of ending. We can go out, we do have some self-generation. We can make power purchase agreements. We could, join with the G&T. All of these options are available to us. They're just certainly not going to be as cheap as what we're paying now.
When are you going to get a turbine from Jackson Lake Dam?
It's been talked about. Go talk to the National Park Service. Okay, interesting. Ooh, this is nice. Katie, did you rework this a little bit?
You did look at the fine print.
I missed it. So, what is our strategy? Yeah, we need to adopt conservation as a serious component of reducing our load growth. So there's kind of three three kind of levers we can pull here. Rate restructuring. So we had a shortfall of $4.5 million. That's what we projected based on load growth. So we could have, increased everyone's rates by, a quarter of a penny, and then we could have made that up. We're like, well, that's not really achieving the goal. So we kind of dipped our toes into a demand charge. So now our fixed rates, our delivery charges are based on demand. So it's pretty clear to see, wow, if I can drop my 15-minute monthly peak demand, maybe not opt in for snow melt on my driveway, I can clearly start saving money each month. And that's kind of to, the carrot and stick approach. We don't want homeowners putting 2,000 square feet of snow melt in. It's gonna happen, but they need to pay for, the capacity to hit their peak. So a small, modest household with this last rate increase is likely only to see, $2 a month extra, as long as they're not running their welder with their electric car charger. So the other lever we can pull is conservation. And so we're a small utility. We've got about 70 members. We have one full-time staffer dedicated as our conservation specialist. So we really lean on ECW. They have, 3 full-time staff at this point. And they're kind of our boots on the ground who can go out and let our members know what kind of incentives are out there, what kind of IRA rebates are going to be available, what BPA rebates are available. We're really lucky. It's really unique to have this entity that's well-funded and really well-respected in the community. And then the last one is demand management. So allowing LVE to curtail load is likely to be really, really important moving forward, especially with the adoption of EVs. And it ultimately plays into this, the ethos of a cooperative where we're all in this together, helping out your neighbor. Small sacrifices can make a big deal. I'll hand it off to Megan here. Unless there's any questions. Yeah. Shoot. Yeah, go ahead.
So as a participant in your solar program, you have Tesla Roof, I think you guys need to do more marketing of that program.
You're saying of our net metering program?
That metering program.
Sure.
I mean, mine made sense because I had to put a new roof on anyway, and with the urban interface with the high fire requirements. So when you equate it out and take the difference, take the 30% return, it made sense to put Tesla roof on the north-facing slope here in town.
Oh, are you up on Snow King on the hillside?
That was the first one.
Yeah. There's no light there. There's no sun. He's
Exactly what I wanted you to think.
okay.
I generate about 7 months of the year of my power now.
Oh, amazing.
But I think you guys need to market and push that more. It's a great program, the net metering. And with the 30% for the homeowner and stuff, depending on when you're doing it, if you gotta replace a roof and you have to pay for a fire-resistant roof, the difference isn't that much.
Sure.
And you guys push it if you wanna get more self-generated power and lessen your load.
Yeah, it's something we really don't advertise too much. I think you'll hear a little bit more about it. We're developing a community solar project, so individuals who aren't ready for a new roof or don't have the capacity to add panels can opt into this, and it will also have the net metering benefits. So I can let Megan chat about that briefly, but that's something on the horizon that's exciting. Okay.
Thank you. Awesome. Hi, everybody. My name is Megan Jennings, and I am the program manager. Let's pass the screen at Energy Conservation Works, where I lead the residential loan program, which I'll discuss shortly. But first, let me introduce ECW. So we are a joint powers board composed of Lower Valley, Teton County, and the town of Jackson, and we also have 5 citizen board members. The ECW team is dedicated to connecting people with the opportunity to save money and reduce electricity usage. And a key focus of our mission is enhancing energy efficiency, which is the topic that I'll be diving into today. And I'll provide an inside look at the homeowner experience with energy efficiency projects illustrated through a couple of case studies. But before we jump into the case studies, let me give you some background on the loan program that I oversee. So partnering with Lower Valley Energy allows LVE members to finance energy efficiency retrofit projects, circled on the right on the loan information document, through both our loan program and on-bill financing. The program is supported by a $750,000 revolving fund for energy projects from the Wyoming Energy Authority, renewed by ECW in 2011. To qualify, members must have their utility bill and their name and a 12-month history of on-time payments, and if eligible, they can borrow up to $25,000 at 1.5% up to 5 years. ECW manages the program while Lower Valley handles the paperwork and holds the loan funds. And at the bottom of the slide, you'll see a high-level overview of what it looks like to complete a project from a homeowner's perspective. So now let's see how this plays out in real life. So meet the Smiths. As a disclaimer, this is a free photo from Pexels.com, and the two projects that I'll be discussing are based on real case studies from Lincoln and Teton County, Wyoming, though I've changed the names in some of the stock photos for privacy and to keep you all entertained. So here is your cute Jackson family and their dog that I've named Leo. So one day, Mrs. Smith reached out to me, and she described their 1980s Rambler DIY house as a fixer-upper. And for their renovation, they were focusing on 3 main areas: air quality, roof integrity, and safety. And she mentioned having an energy audit completed in 2016. Ms. Smith shared her motivations for the project. She noted that all of their baby monitors indicated unhealthy air quality. In the summertime, heat radiated into their pizza oven bedrooms long after the sun set, and in the winter, the poorly insulated crawl space left their feet freezing. Pulling up the audit, I saw that improving air leakage and insulation was a highly recommended in addition to the concerns about air quality. And for those of you who may not be familiar, a home energy audit is an assessment that evaluates a home energy use and identifies opportunities for improving efficiency, which is crucial for understanding specific needs and promoting efficiency in energy-saving projects. These are fun. Here are the thermal images taken through the Smiths audit, and the purple areas actually indicate areas where the cold air is seeking into their home. So you can see on this middle one, this is the ceiling picture, and you can actually see the cold air coming down into their house. So the Smiths proceeded to go with 2 key upgrades: an energy recovery ventilation system, or ERV, and improved insulation. They wanted the ERV to reduce the overall carbon footprint of their home and lessen the energy burden of providing fresh air. This proactive approach helps minimize exposure to indoor pollutants like carbon dioxide, volatile organic compounds, or VOCs, and bacteria. They were also excited about insulation, which would significantly reduce heat transfer, energy loss, and stabilize their indoor environment. Once they defined their project scope, they consulted 2 different contractors for the insulation and ERV, and the costs were $57,000 for the insulation and just under $8,000 for the ERV. So now let's look at some financial incentives. So this is the ECW residential loan program info paper that you saw earlier, and the Smiths were able to qualify for the program and allow them to take out $25,000 at 1.5% over 5 years. They also qualified for a Lower Valley Energy rebate and installed 557 feet of spray insulation and qualified for $891 in Lower Valley Energy rebates. They also worked with a tax professional to claim the $1,200 tax credit for insulation. And so in total, the Smiths received a little over $2,000 back and financed 38% of their project costs with a loan that required $432 a month over 5 years. And after completing their projects with our assistance, the Smiths were extremely satisfied with the outcome, a more efficient and safer home. Now let me introduce you to Tanner. Tanner is a Wyoming native from Afton, just south of Jackson. About 2 Marches ago, Tanner reached out to me after receiving his audit, and he wanted to learn more about the ECW loan program. When I first spoke to Tanner and received his audit, it was clear that he was laser focused on the recommendations outlined on the first page. The opportunity stood out, upgrading his current electric resistance system to a system with heating and cooling and is 2 to 4 times more efficient. And when we met over Zoom, Tanner told me he looked into his energy usage and was motivated by the desire to conserve electricity and save money, making a heat pump system a great fit. Tanner decided on a ductless mini split system with 1 outdoor unit and 2 indoor wall mounted units. He consulted with a local contractor to supply and install the system with costs of about $11,000. And now let's look at the financial incentives for Tanner. So Tanner also qualified for the ECW loan program and was able to finance 100% of his project costs at 1.5% over 5 years. He also qualified for Lower Valley's $650 rebate. And Tanner also worked with a tax professional to claim $2,000 of his tax credit dollars back. And so all in all, Tanner received 23% of project costs back in rebates and tax credits and was able to finance 100% of his project costs with his loan, resulting in monthly payments of just $195 over 5 years. And I checked in with Tanner after the installation, and he told me he won't be going back to conventional electric resistant heating anytime soon, and that his heat pump is a dream. Since 2012, the ECW has successfully completed over 170 loans, making this program an effective way to reduce upfront cost for energy efficiency retrofit projects. And if anybody would like to discuss the loan program or any other topics I've covered, we'll have time for at the end. But now I'm going to pass it back to Katy, who's going to be talking a little bit more about new construction.
And does anyone have immediate follow-up questions for Megan before we do switch?
Are these income qualified loans or rebates?
No, we just asked that the requirement is that they have to have 12 months of on-time payment with Lower Valley Energy. So they have to be an LVE member, and then the meter has to be in their name. But we don't do any credit checks or anything. No, that's all we need. We've just found that having people pay their bill is a better or good enough indication if we're going to get paid back on the loan. So we've kind of gone with the if it's not broken, don't fix it. Lower the barriers for people. Mm-hmm.
How many staff administer your program?
It's just me. It's me, and then I work really closely with Lower Valley, as Max talked about, the conservation specialist. Yes?
If I don't know the best option for my house, would you be able to help me figure that out?
Definitely. I love to rely on the energy audit and walk through the different things. And we can't endorse any contractors or anything because we are a joint powers board and a public entity, but we can provide people with contractor lists that have used the loan program in the past. So that is our one limitation, but the audit is a super helpful tool. Any other questions? Yes.
Finding that in a lot of areas we find that heat pumps and hybrid systems don't have a lot of contractors who are qualified to take care of those systems. I would assume that you're kind of building that knowledge base as well here, is that right?
Yeah, I would say this is the only heat pump that I've managed the loan for a little over, or the loan program for a little bit over a year now. This is the only heat pump project that I've done. So I would say it's definitely still like a work in progress. That's not to say that it's not being completed in Jackson or that people who don't need the loan program aren't doing these projects and we just might not be aware of them as well. In the back.
I'm on the Victor City Council, and we have a person who came to us and asked for forgiveness on his water bill because he says he leaves his water pipes on all winter long. Is this something like, I mean, whatever, I know you don't serve Victor, but do people come to you with problems
I would say if people have like an energy problem that they're using a lot of or wasting a lot of energy, or like my bill is really high, they'll typically come to Lower Valley with a question, and then the conservation specialist will typically point them in the direction of an audit. We have a really awesome, Scott Paulson actually lives over on the Victor side, and he's super knowledgeable and would highly recommend getting in contact with him, or I can put you in contact. But I would just say an energy audit is one of the most useful tools. It's basically a home energy checkup and tells you what's wrong. Yes. Definitely. Yeah, so that's the beauty of an audit, especially if you haven't done a lot of upgrades to your existing home. I actually completed a... Yeah, there was somebody who came, actually the Smiths project, their audit was from 2016, and that was completed this last spring. So we can definitely look back at old audits. Any other questions? All right, now I'll hand it back to Katy for new construction.
All right, so we're going to switch gears and talk a little bit about the strategy and some of the technical decisions that were made for a multi-home development up in Bozeman called Bridgerview that we consulted on. Bridgerview is a 62-unit development that was built in 3 phases. The final phase was finished about a year ago, and it's a very it's a designed to be kind of a very walkable, community-centric rather than car-centric design. It's a really beautiful design. It's a mix of single-family, some single-family detached homes, some duplexes, some townhome-style 4-unit buildings, and then a couple small multifamily buildings. Kind of the flat style with like one is 2 unit, one is 4 units, and then there's a small community building. Really beautiful project. So this was Montana's first Department of Energy Zero Energy Ready project, was essentially is Energy Star, which is actually a great program if anyone's not aware of it. It's mainly prescriptive, but just a bunch of like common sense stuff everyone should really be doing, but with some additional requirements on top. But it's really just a pragmatic, practical, great program. Highly recommend this program. Also did LEED Platinum, and then LEED ND is LEED for neighborhood development. And and this is just one example home of one of the detached farmhouse style buildings. So this project was really aspirational. They really wanted a project that was resilient, so that, again, if the grid was down, homeowners would still be comfortable. And a budget is always a challenge. This also was being designed during COVID, and where prices were skyrocketing. Once construction started, there were various supply chain challenges where windows needed to be changed. The sheathing initially looked like it needed to be changed, and then zip was still available. But at the end of the day, where this project landed was they decided it really did make sense to focus on the building envelope first, rather than kind of doing a code level building envelope and fully outfit it with heat pumps to serve all the spaces. They decided to invest more in the envelope and do kind of a more hybrid mechanical system, which I'll explain. But some of the high performance envelope features were the dense packed cellulose in the cavity walls. They did the zip system sheathing. Essentially, it's an adhered weather resistant barrier. I'm a big fan of that. And then outside of this, they did a 3-inch nail base wall panel, rather than kind of separate insulation and then another kind of layer of sheathing. They just did this nail base panel, and then the contractors were basically working from a substrate that they're used to, rather than like kind of doing furring or like anchoring siding through 3 inches of insulation, which can be challenging to hit studs underneath and kind of cause issues with massive fasteners. So anyway, that was where they landed for the outside of the building. And then you see the steep peaks on the sort of traditional architecture, but to insulate the peaks and to have conditioned space in the attic, it's a big cost add. So they ended up doing vented attics, and with just a bunch of cellulose blown in. So we had to do the air barrier on the bottom of the trusses, and it's these buildings ended up testing on average between about 0.9 and 1.2 ACH50. So again, that passive house level is 0.6. And with the air barrier at the bottom of joists, and it's tough to, there are a lot of details that need to be handled right. I really didn't know how it was going to go because we had not done a project that didn't have the airtight barrier at the roof sheathing before that got a really high level of airtightness. And we were just really pleased on the very first blower door, the first unit hit 0.8, like in the mock-up unit. So this is an Intello, a ProClima Intello product, really robust air barrier that, is holding the blown insulation in that went in on the attic, and that just needed to be taped well to the top plates. And you can just see some other details. These use Alpine windows. Alpine are what I like to call like a faux triple pane. There are 2 layers of trapped air, but the middle layer is actually suspended film. It's essentially like a low E film in the middle of the window. And one really nice thing about Alpine in high altitude areas like Bozeman or like here in Jackson is these are fabricated in Denver. So they don't require being shipped with capillary or breather tubes, which will just leak argon out. It will, no matter what anyone says. And argon it increases the U value of the insulated glass unit by about 20%. So it's a big deal, especially when you're in a cold climate. But something even more unique about Alpine, you can see the little blue thing there. That's actually a balloon. So they ship their insulated units with this balloon that's connected to the insulated unit. So that can like absorb and contract to deal with, driving over mountain passes, or maybe these are actually going to be delivered at sea level without, again, distorting the insulated glass unit and having it break or have seals fail. So we like the Alpine products, but one thing I definitely would say is on any cold climate project, be sure you're doing your homework on windows that can actually be delivered to the site without breather capillary tubes. It really makes a big difference. I think people often go right to aesthetics at the start of a project. That's sort of what they make their short list on, and then think about the technical things later. I would really encourage, start with making sure the performance requirements are clear, and then get your short list of like who has the nice looking hardware and colors and whatever. And there's a blower door test happening. So those are some highlights on the envelope. And then the systems, so again, budgets, value engineering hit this project like any project we ever work on. But where they landed with this was it was just going to be so expensive to do like a fully ducted system and have heat pumps serve serve all the spaces in this home. So where they landed was what I call kind of this hybrid system, was they just did a really simple single zone, 1-to-1 mini split. Here's is there a laser on here? There we go. Yeah. So there's the outdoor unit. You can see a nice, cute little, suitcase size unit hanging on the outside of the wall. And that is connected with insulated refrigerant lines to this one indoor unit. And because of design temperatures and the typical engineer maybe being a little conservative, they did insist on having this backup heating on the same zone, so that's cove heat. And something we insisted on, though, was to have one thermostat to control both systems. Because, something I've seen, and in theory it can be handled by homeowner education, but, you never really want to assume, you want to try to make things simple, is there are 2 thermostats and someone's feeling chilly, they're like, oh, I'm going to turn the heat up. Well, what if you turn up the electric resistance backup heat above the mini split? That's what's going to be providing the primary heat. So there are, you need to spec really carefully to find a control that will work with the electric resistance and the heat pump, make sure they play nicely. One point of feedback I've heard on this project is that some homeowners they're challenged by this control. It's not even, it's more advanced than your programmable thermostat, which some people struggle with. So anyway, controls definitely are important to spec properly, but they can be a challenge on the operation side. So then each home has an energy recovery ventilator and heat pump water heater as well. These heat pump water heaters are in the basement. And these basements were provided unfinished, but there is an egress window. And And it will, you know, these units in a basement will cool down the space, but it's not going to cool it down by like 20 degrees. What we typically see is between like 3 and 5 degrees. So just wanted to share a little bit on how some of these systems actually play out, you know, in real life. And I will share a little bit. Again, really sorry for being at the final hour now and starting late. I will show, if anyone wants to talk more about heat pumps and what the challenges are in cold climates, I'm certainly happy to stick around another 10, 15 minutes for Q&A or just chat afterwards for any questions that you have from me or Max or Megan. I will, you know, just briefly touch on some of the differences in mini splits. So what you saw was probably what you tend to think of if you hear a mini split heat pump. It's a ductless unit. There's an outdoor unit, connects with refrigerant lines to the indoor unit. And, you know, not the prettiest things. But there are a number of different unit types. So, but that is a typical kind we see. It's the split unit, split ductless, but you can duct mini splits. So, you know, you can duct that outdoor unit to an indoor fan coil and duct with a register. You know, this is kind of a more standard register, but you can do anything you want with the register. You can have it be like the kind of fancier, thin, you know, thin linear register, which is really popular in a lot of our projects now. It looks more modern. But even the ductless ones, you know, you can kind of hide above a cabinet or above a refrigerator. Can look pretty nice. These new units we're really excited about. These are packaged units. This is like the version, you know, 10 of the awful PTACs we're used to in motel rooms that start like a jet engine and wake you up every like 10 minutes. But these ones aren't a big mass of metal through the wall. This actually sits entirely inside the wall. And rather than the heating in a PTAC being electric resistance and a PTHP, package terminal heat pump, it's also a heat pump doing the heating. And these have just 2 small ducts that go out. So one that's bringing the outside air in, and then the exhaust, which is, you know, the exhaust is either rejecting cold or hot air, depending on whether you're, you know, heating or cooling. But yeah, those are the typical options for these latest versions of efficient heat pumps. And, you know, just to kind of show you what that looks like, we've got that outdoor unit. It's connected with refrigerant lines, insulated refrigerant lines to an indoor unit. And just hugely versatile in terms of going to a ducted indoor unit or just individual heads. There are these units look ducted, but they're actually ductless, these thin ceiling style. They're also, depending on the manufacturer, you can get something similar that fit into a vertical wall space. So that is it. Sorry, we kind of flew through that. And the last thing I'll close on, I went to the HOA presentation, and I really appreciated that the moderator said, okay, what's one action item you can write down you're going to commit to doing? So I'd love to challenge all of you with doing one or more of these action items. One is you can sign up to join this forum at the Mountain Town 2030 Climate Network. If you scan this, that will take you to that page. You actually need to like be accepted in. I signed up 2 months ago and I haven't actually been accepted yet. So if any Mountain Towns people are here, just a request to be sure to monitor those and accept people so then we can get some good collaboration in that group. And then oops. Oh, did my computer go dead? Well, I don't know. The second one there, we're working on this new initiative called Building Genius, which is trying to package information and expertise. So if you want to check that out and just join for free, you can also kind of participate in a group. We can have extended conversations about cold climate heat pumps, heat recovery, ventilation, any nerdy technical stuff. That website is Building Genius, buildinggenie.us. And then the final thing for anyone local here or anyone who wants to come back after winter arrives tomorrow, next Friday, the 25th in Wilson, is a mini kind of event conference focused on a lot of these topics that we talked about today, high performance building envelopes and heat pumps. And that's called Building Better in Cold Climates, buildingbetterjh.org. Right, Matt, is the website. So it's going to be a great group. It's free, but you're going to be bussed around, get food. So anyone that's around that doesn't know about it would be great to see you there. So thank you.